Good afternoon, everyone. Thank you for joining us today on our series of energy resilience workshops. Our first session that we're holding with Centre for Sustainable Energy today is about an introduction to retrofit. So just to give you a brief introduction, my name is Julie Raymond. I work for the social investment business. I'd like to introduce my colleague, Robin Bell and Steve Cole from the Centre for Sustainable Energy, who'll be picking up with you a little bit later on. As a brief introduction, the social investment business works with charities and social enterprises across the UK. We provide a mix of loans and grants and have deployed and managed over £800 million since 2002 and supported over 6,000 organisations in the UK. We started working with CSE around 12 months ago, and they are our key partner on our Energy Resilience Fund. They provide support to applicants around advice and suggestions on how to improve their energy efficiency. This afternoon's sessions aims to give you a brief introduction to the world of retrofit, and we'll be covering a range of subjects, including what retrofit actually means, the reasons to do it, and some of the options that may be open to you, and of course, how these can be funded via our Energy Resilience Fund. During the session, there will be a live Q&A box, so if you do have any questions, can you please post them in that box, which should be in the tab bar at the bottom, and our team will do the best they can to answer them as we're going along. And we will also have some time at the end to ask any general questions. If you do have something specific related to your own building, can I ask that you pick that up with us at a later date, and it will just be more general questions today. Just following on from today, the slides will be sent out after the session, and they'll also be available on our website with some key takeaway points from today's session. So to kick us off, I mentioned before that we have an Energy Resilience Fund, so I'm just going to provide a bit of background to that. We launched the fund about a year ago, and it's the successor to a pilot scheme run by Key Fund. It's for organisations based in England and is there to support you to become more energy resilient, either through property improvements or more efficient equipment and vehicles. It's a £15 million blended finance package of loan and grant. So every successful applicant will receive 60% loan and 40% grant of their request. We work with a range of partners. This slide shows you just some of who those partners are. When you apply, you'll get a drop-down list. You'll be able to pick whichever partner you wish to work with. So it might be somebody you already have an existing relationship with, or you feel better suited to your type of building or work. So in terms of ERF and what can be funded, there's a huge list on here. There's a lot more information on our website, and there's case studies on what can be funded on there. But I think from things we've funded so far have been everything from solar panels, electric showers, minibuses, air source heat pumps, insulation, and an electric tractor. The fund terms are shown here. Again, key points to take away from this is that the minimum request is £25,000 and the maximum is £250,000 per organisation. As I mentioned, it's a 60% loan, 40% grant. Loan term is anywhere between 2 to 10 years, and the first 12 months can be offered on an interest-only basis. It generally will be an unsecured loan, and there's no early repayment fees. All our key eligibility criteria, all our information about the fund, anything else you need, frequently answered questions, all of that is on our website, so please do visit that after this session. The key points in terms of the eligibility, as I mentioned before, it's for organisations based in England. You need to be incorporated, have a minimum of 2 years operating activity, and a minimum turnover of £100,000 in your last set of annual accounts. A key point around this is that we offer funding for both property refurbishment work and also equipment. If you are looking to make improvements to a building and that building is leased, we do need you to have at least 12 years remaining on that lease. If it's not leased and you own it, that isn't an issue. It's just if it's a leased property. So a little bit more about the process is that everything is online. You apply via our website, and as I said before, a huge range of guidance and advice to help you with that. We'll ask for various supporting documents. That includes 12 months energy bills, so just remember to start preparing those before you apply. Again, as I mentioned previously, that you can choose whoever you wish to work with. That's not an issue. Just choose the best fit for your organisation. Where you are applying for property works, we will require an energy audit. So that should be something that's been done in the past 2 years. We have some criteria that needs to fit. So if there's anything you're not sure about, give us a shout and we can talk you through that. If you don't have an energy audit, that isn't going to stop you applying. It's something that we can fund via the ERF fund. Just to point out, though, that isn't a standalone part of the fund, so you can't apply just for an audit. You need to have a clear idea of what you're looking for, and that's something that CSE can support you with as well. So in terms of our energy audits, just a bit of background about those. They are carried out by one of our 3 providers, and they will work with you. They will come out and do a site visit and work with you on terms of looking at what your building can and can't do. It doesn't matter which auditor you get allocated. They all produce the template form in the same format, so everybody will have the same information provided. Once you've had that audit, you can then again work with CSE and the auditor to agree what sort of work is going to suit your building the best, what is going to have the best payback periods, that type of thing. And then you can come back to your relationship manager and work with us to get through that process. If you're only applying for equipment, so if you're only applying for a vehicle or things like floodlights on a football pitch or something like that, then we won't need a lot of that information and you won't need an audit. It's a much more straightforward process. Throughout the process, you will have a dedicated relationship manager and they will support your organisation and work with you continuing after the investment has been approved as well. So I appreciate that's been a very quick whistle-stop tour of the fund. I'm now going to hand over to Robin and Steve from CSE, and then we're going to give you a bit of information on retrofit and what it means. Thanks.
Okay, just checking you can see our slides. Introduction to retrofit.
Yep, all good, Steve.
Perfect, thank you. Okay, hi everyone. So in the next sort of 40 minutes or so, we're going to take you through a good few slides just to kind of give you an overview of building retrofit, what it means, some of the key things to consider. But just before we do that, just a quick overview of who we are. So we're the Centre for Sustainable Energy. For those of you who don't know, we're an energy charity. We're based in Bristol. We have kind of quite a few strands to our work. One of the main ones being that we're focused on ending the suffering caused by cold homes and also combating the climate crisis. We support people in fuel poverty through an advice line and a building retrofit team covering domestic and non-domestic buildings. We also support community organisations on energy, fuel poverty, retrofit, and also local and central government with decarbonisation and energy plans. And as Julie was saying, we also support the Energy Resilience Fund application process with some technical buildings advice. So just quickly, today we're going to cover four key areas. Firstly, the reasons to retrofit, some key principles when you're planning this kind of work, the types of audits and surveys you may or may not need, and also some of the sort of most common building fabric retrofit measures and considerations. So first off, you might have heard the term retrofit in the news, in the newspapers, and sort of bandied around with people. Basically, in the simplest form, it means any kind of improvement work to an existing building to improve its energy efficiency. So we're adding things like insulation, air tightness, draft proofing measures, mechanical measures, electrical measures, technology that will help to reduce its energy consumption and make it more energy efficient. So what are the reasons we retrofit? Well, there's quite a few, and it kind of depends on your circumstances. And it sort of depends on what path you want to follow, what your priorities are, what your biggest priority is, whether it's saving money, improving comfort, and possibly, securing the long-term viability of your building. So it can be to improve affordability, to reduce energy bills and overall running costs, Like I said, it can improve comfort. This is really important if you have a kind of a care or support function in your building, or it might also be connected to the viability of the building. So the more usable the space is, the more likely it's going to be used and the more comfortable and attractive it is. It could be to actually open up any unused space that you've got in your building. It could be, something a bit more urgent. It could be a trigger point. It could be that your boiler's broken. Maybe you don't necessarily have a long-term plan in place, and it's a reactive decision. Your boiler's broken, or the roof is leaking, or there's some other issue that needs kind of urgent attention. It could be maintenance or repair related. And this again can be, a reactive thing. There might be an urgent need to repair a certain part of the building, and it makes sense to do some retrofit work at the same time. It could be that there's a legal requirement. It could be that you need to comply with legislation. It could be health and safety, energy efficiency, fire related. There's all kinds of different circumstances. It could be that you've got a heritage building. Maybe it's listed, or it's in a conservation area. It's got some unique characteristics that might be under threat if you don't do some work on the building and to maintain it and improve its efficiency and viability. So this also could be a motivating factor. And then there's a couple of things which are sort of related to, if you like, strategic priorities. So the organization itself, its reputation. Are you, tasked with making carbon savings, with improving resilience, but also locally, is it an emergency shelter? Do you form the role of a warm or a cold hub? So there could be many reasons to, take this step and, think about what you can do to make your building more viable, more attractive, and lower cost to run. So I guess, longer term resilience against energy cost and improving financial viability. So it can include many things. And when you talk about retrofit, lots of people think, oh, okay, it's maybe just energy efficiency. But actually, there's lots of other elements that kind of surround that. And retrofit can be relatively sort of a short-term focus, but there's a longer-term focus that perhaps we all should be keeping in mind. And that's things like, what can we do around flood prevention or mitigation? If we've, the climate is becoming more unpredictable. This can be both coastal flooding, can be groundwater related. So is there measures we can undertake on our building or grounds that help with flood prevention? Can we reduce our exposure to wind-driven rain? Storms are becoming a bit more intense. We're experiencing more extremes of weather. Are our rainwater goods and drainage systems able to cope with this? That's something else to think about. And also then there's the other side of the coin. There's overheating risks. It's not necessarily all about the storms and winter. It's also about summer. Have we got lots of south-facing glazing? Does our building overheat in the summer? Is it poorly insulated? That also plays a part in overheating risk. And then also alongside that, there's ventilation. Ventilation is becoming more and more important to prevent high humidity and mold growth and provide, a really comfortable, well-ventilated indoor environment for people to use. So we have lots of current building stock, and it makes sense to retrofit those first. And, you probably maybe heard this, the most sustainable buildings are often the ones that already exist. And this is often better than trying to build something new. And we sort of estimate by 2050 that 80% of the buildings we have now will be existing in 2050. So they're already built, and there's a lot of heritage value that we need to maintain. So, successful interventions around retrofit can lead to the continued use and care of these buildings and preserve these features for the future. And then also thinking about embodied carbon. This is the carbon impact of new buildings. So producing new building materials and building new buildings produces a lot of carbon and uses a lot of energy. So retrofitting is a way to avoid a lot of this waste and avoid these emissions that all come from new construction. So now we're just going to move on to some of the key principles around retrofit.
This is you. Okay. So yeah, I guess the first bit is, do no harm. There are lots of things you sort of can do to a building that might not necessarily always be a good idea. So we always sort of encourage people to, keep a few of these things in mind. So do no harm, do your assessments, do some monitoring, talk to the people in your building, understand your current situation, what you've got. Be aware of things like repair and maintenance. Do you have any outstanding repair and maintenance issues that need dealing with, or are you planning things in the future? We try to get people to think about what we call a whole building approach, which we'll get into a little bit more, but where possible, we're trying to encourage people to look at the building as a whole system, and how it all works together, as opposed to just focusing on individual elements. And then we'll also go through something called Fabric First, what we mean by that, and also what we don't mean by that. There we go. So, yeah, in a climate emergency, many people want to do something, but not all interventions are necessarily a good idea for you and your building. Retrofit is not rocket science, but how heat and moisture move through a building is fairly poorly understood. So it's a good idea to try and understand some of the risks before we take action. Thanks. So when we talk about assessment and monitoring, we are talking about assessing the building's condition, its age, its method of construction, its location, and the site specifics. Monitoring can be really helpful, so that might be monitoring your energy usage using things like a smart meter, or it might be looking at things like indoor air quality, relative humidity, air temperature, CO2 levels. So there's a lot of things here that can sort of inform our decisions. So yeah, understand what you've got, how it's used, and the potential impacts of a changing climate. Understanding causes and possible solutions for each issue, such as damp and mold. So you need to remember that every building is different, no matter how similar they appear. So just because you've seen some advice for a different building somewhere else doesn't necessarily mean that that will be the right approach for your building in your situation. So this little picture here is just trying to get us to think about some of those things, how our buildings are used, what they're used for, what sort of building services, so that's heating systems, ventilation systems, lighting systems. Oh yeah, there's quite a lot to sort of look at. Repair and maintenance seems to get overlooked by lots of people, but it really is quite important. So maintenance, periodic renewal, and conservation-focused refurbishment have the potential to save between 30 and 50% of carbon emissions, and save up to 40% in energy consumption. Maintenance makes a building retrofit ready and should be done before undertaking larger measures. Repair and maintenance in itself, I would argue, is a sort of energy efficiency intervention, and it really is the sort of cornerstone of looking after our buildings. So briefly mentioned this whole building approach. So as sort of said, it tries to focus on the whole system, not individual elements. And we need to be dealing with specific situations as opposed to generalities. Opportunities and constraints can vary widely, even if buildings appear similar. So building and site-specific approach is required to find a bespoke and balanced solution. So why we do this is because by taking a whole building approach, it can help to highlight and resolve any uncertainties, reconcile any conflicting aims, and manage the risk of unintended consequences. So this picture here is sort of trying to highlight that the actual performance of a building is often a bit of a balancing act. So we've mentioned building services, heating, lighting, ventilation, The building fabric, so that's things like the walls, the roof, the floor, the doors, the windows. Our community buildings are used for a variety of different things by a variety of different people. So the people sort of underpin a lot of this, because the people are the ones that do the work on the services, that do the work on the fabric, that use the heating systems, and they're the ones that use the building. So it really is important to try and think about all these things together. So fabric first is a bit of a retrofit mantra, and there's a bit of confusion around what it is and what it isn't. So it does not mean that we need to cover all of our buildings with polystyrene, as this may not be appropriate, practically possible, or even a good idea. Fabric first does mean that it is sensible to make targeted improvements where appropriate, safe, practically possible in areas such as lofts, bay windows, etc. So a building fabric should be assessed before installing fabric measures. Sorry, I said that wrong. A building fabric should be assessed for installing fabric measures before installing any new mechanical systems. So ideally, we want to be reducing energy demand before we're specifying any new heating systems.
Okay, great. So as part of this process, and obviously as part of your possible application for the Energy Resilience Fund, there's an energy audit opportunity that Julie mentioned. But we're just going to sort of cover that, but also we'll cover some of the other kind of audits and surveys that might be useful either now or in the future as sort of a wider perspective. So generally, when we're talking about retrofit, we talk about a sort of a circular process, and it might be that you never necessarily complete the circle, or that you complete it several times over several different periods of time. But we always start with gathering, if possible, gathering some baseline data. So that could be some simple things like energy bills. It could be monitoring and assessing your indoor environment yourself if you're able to. Get some air quality monitors and monitor the temperature and relative humidity and CO2 levels, just so you understand, sort of what's going on in your building. And, if people may have commented, oh, it's a bit cold, or it's a bit stuffy, or it's drafty, or it's too hot, those kinds of things, it's really worth just trying to understand what's going on yourself in your building at certain different times of the day and year, so you can sort of build up a picture of how it works internally. And then combined with that is this sort of audit and survey process. So this really kind of informs the decision-making process and sort of covers, the fabric and the services and how it's used, as Steve was saying, is really important. Your energy use, your indoor air quality, all the humidity and carbon dioxide levels, but also the influence of the outside surrounding environment and your exposure to, perhaps flooding risk or wind-driven rain, or, if you're in a particularly hot, dry location, or you're exposed or you're shaded by other buildings or kind of trees or topography or whatever it might be. So it takes into account that whole kind of local and indoor environment. And then comes with assessing the options, maybe sort of conducting some feasibility studies, and then thinking about sort of building a case for the work you want to do. And most likely, whether you have, directors or a committee, there's more than probably one person involved in the decision making. And also important for the application process for the fund is building that sort of sense of a case of what are you trying to achieve, reducing carbon emissions, reducing energy costs, securing the long-term energy security of your building. We're seeing some real volatility in prices of gas and oil at the moment for obvious reasons. So it'd be great to try and, insulate ourselves as much as we can from those kind of shocks. Is it, creating more comfortable internal environment? And this also can lead to things like increasing the market value of the property that you have, and avoiding, things like stranded assets if the buildings become, more and more dilapidated or unusable for any particular reason. These are all really compelling reasons to go down this path. And then the next stage is, looking at sort of detailed design and specification. So that's sort of seeking professional advice and considering the kinds of materials you might be using for insulation. Is that compatible with the building? The sort of levels of carbon impact, and also things that influence and should be thought of is things like moisture movement, air tightness, and ventilation, which we'll come on to a little bit in a few minutes' time. And then there's a sort of feedback loop. So, you've assessed your options, you've sort of prioritized and thought about what you want to do. You go ahead and make those changes. And then it's always a good idea to sort of monitor that and to keep assessing, what's happening in the building. Have you achieved the sort of comfort levels you wanted to? Is your energy levels reducing? Energy consumption reducing? It might be that your energy consumption hasn't reduced, but if actually you've introduced or reopened up unused space. So you could be that this work has allowed you to use more of your building and make it more comfortable, which makes it more viable and more of a valued community asset. But in the long term, it might not actually reduce the energy consumption, but you're getting a greater use out of your property. So there's lots of contextual elements, but we really kind of recommend developing a whole building approach and a whole building retrofit plan to work through and plan this whole process before you get going. And also another thing is to think about any sort of permissions, planning permissions or authorizations you might need if you're listed or in a conservation area. So that should form part of this. So as part of that, obviously, there's lots of different types of audits and surveys. You're probably familiar with the energy performance certificate, and you may have a display energy certificate. Just alongside that, as an organisation that's involved quite heavily in this part of the construction industry, we have our own walk around DIY survey, which actually is a really good place to start, just to get a sense of what's going on in your building for your own kind of knowledge and information. And there's a link to that on our website, which I think we share in the notes that accompany the webinar. Then, of course, there's the energy audit that's provided by one of 3 providers as part of this application process, and that will look at the energy consumption, the opportunities for energy reduction, what measures you can install, and should also, I think, include some indication of carbon savings. And then also part of that, there's a thermal imaging survey, which I'll come on to in a second, a building condition survey by a professional surveyor, heating survey, and solar surveys are all other aspects. So thermal imaging, apologies for the slightly blurry images, but basically they all indicate in these examples areas where there's heat loss, and that's indicated by the darker areas in the images where there's cold air or cold areas of building fabric or gaps in insulation. So it uses a special camera to measure the sort of temperature of the building fabric. It's most useful in the winter when you've got a higher contrast between indoor and outside temperature. And you can often, loan a camera from a library or a local council, or you can, even purchase an add-on to your phone for a few £100 to give you a sort of a basic sense of what's going on in your property. Another one is a building condition survey. So this is a chartered building surveyor, construction professional. Some energy assessors also do this, but they look at the structure of the building, the roof, the walls, the windows, the doors, but also electrics. Have you got any hazardous substances, materials such as asbestos? Your utilities, sewage provision, fire safety. So basically, it's a survey of the whole building, and it gives you a level of rating against condition from A to D, and also a priority in terms of what you should look at in terms of immediate attention right through to kind of long-term attention. So that can be a really good option if you're kind of unsure about many different aspects of your building, or even if you don't have the time to sort of look at it yourself, it can be a really good way to get a really thorough overview of the premises. Something much more specific is a heating survey. So this would be a heating engineer. So they're a professional who essentially design, install, and maintain and repair all kinds of mechanical systems within buildings, so heating and ventilation, air conditioning, etc. And they'd look at the existing system you have, its condition, its performance, its efficiency, They can make recommendations about alternative options, upgrades, or even replacements. For example, it might be that you've got a gas boiler that's coming to the end of its life, and is it sort of viable to maybe replace that like for like, or maybe to consider other sort of low carbon options like some sort of heat pump. They can carry out maintenance, and that in itself can improve the efficiency of your system, safety checks and performance checks. But it's really important if you're considering a new heating system to essentially assess in depth what kind of options are available. And the person to do that would be the heating engineer, to give you that really detailed kind of technical analysis. And then something a little bit more high level, and actually could be a really good investment, is a solar PV array. And we have a handy tool online which is called Solar Wizard, and this is just really a sort of high level online assessment, and you can generally put your postcode in, you can find your building, and it sort of works by looking at the roof size and the orientation and the tilts and the angle of the sun, and gives you a sense of how much power you could generate from your roof space, the return payback periods, total annual savings, estimated insulation costs. So it's quite high level, but it just gives you a sort of a top line sense of what could be possible. But things to consider are the kind of profile of your energy use. When do you use most of your energy? Is it during the day? Is it in the evenings? Is it at night time? Who would own and connect the solar? And also, would you need any permissions? Is it a listed building? Are you in a conservation area? In fact, do you own the premises that you would want to put solar on, or is it leased? So who would you need to speak to about that? So some of the key points around this are, it's quite important if you're doing a survey of some kind, is to involve staff, as they may have sort of first-hand knowledge of how the building performs, and any rooms which are particularly cold and drafty, or any areas that need attention. As I said, really important to think about maintenance, and to have a planned preventative maintenance program. So you're sort of regularly checking the condition of your building before things deteriorate. And it depends on your priorities really, and motivation. So, if you've got a brand new heating system, you don't need to get a heating engineer to do a survey. It's really making it relevant to what you need. And also the nature of the funds and the funding requirements will shape the nature of the audit. And it's a part of the puzzle. It's all about assessing your building options. It's part of the sort of retrofit journey, but a really important part. And as part of that, as I said, it's not just looking at the energy reduction. We should be also looking at how we can adapt and sort of mitigate the risks from sort of climate change and the impacts on our building and premises.
Okay, so retrofitting building fabric. Location and local climate, and I guess most importantly is local context. Like, with different parts of the UK experience weather differently, we're exposed to different things. So the image on the left is a map that's taken from, I think it's part C of the building regulations, and that sort of maps out the geographical exposure to wind-driven rain. So you can sort of see, if we are down in the southwest, we're differently exposed, we're more exposed to wind-driven rain than we are if we're over on the east coast. So again, that's what advice is out there. I guess nationally, we do need to think about that in a local context. So every building performs differently according to its location, its orientation, its design, its construction, their services, their use pattern, and the condition. So construction type plays a key part in this. And I'll talk in a second about traditional and modern fabric. But it's just worth bearing in mind, I guess, the picture in the middle there, the advice and the guidance that you might give to somebody in that building might be very, very different to the advice and the guidance that you give to the building in the right there. So local context is key. So building fabric, that is the components and materials that the building itself is made of: the walls, the floor, the roof, windows and doors. Something called traditional construction. So they're generally sort of pre-1919, but I would say most buildings probably constructed before the Second World War are usually of a traditional construction. Modern buildings, I think, as we've built buildings, the way that we build has evolved over time. So if you have a cavity wall building from 1950 or 1960, that's going to be quite different to a modern cavity wall building. So we do need to think about that. Yeah, it's interesting, I guess, that the last time we had a really large fuel crisis in the 1970s, that led to lots of changes with building standards and rules and regulations around energy efficiency. So generally, things that have been built since then have been built to a different standard than the buildings that were built before then. So this picture on the right tries to sort of talk through a bit of the differences between modern buildings and historic buildings. So most of our historic buildings, we used to let the air in through the windows because that provided the fuel for the fire. The fire used to help with ventilation. We had big, thick walls that they sort of can get wet, but the important bit is they can then also dry out. So they were often built with permeable materials such as lime mortar, whereas our more modern buildings tend to have a lot more insulation in them, and they tend to be built with the idea that they're trying to keep moisture out, and they also rely on mechanical ventilation as opposed to just drafty windows and fires. So yeah, the advice and guidance around dealing with modern and historic buildings can be quite different. Insulation, a couple of sort of general points here. So adding insulation does fundamentally change the way that heat and moisture move through a building. So lots of people think about it as a good way to keep the heat in, but more people need to be thinking about how moisture, or how the movement of moisture is then affected by this. Adding insulation won't solve your damp problems. Solving your damp problems, understanding what's causing them, is probably a good step towards solving them. Some places can be relatively simple if you've got loft space with and flat ceilings. Others can be practically difficult and risky. It's often sort of said that adding less but doing it better and more continuously can be better than trying to add lots and leaving gaps everywhere. So there's interesting studies here where different gaps can really undermine the effectiveness of the insulation that you've got. And it's common that you sort of see issues around junctions. And what I mean by that is where the roof meets the walls or where the wall meets the floors. And also around service penetration. So anywhere where you've got pipes or cables that are going in and out of a building and passing through the building fabric can cause complications. So there's a few more fun thermal images there on the right. And I guess the one on the left is sort of showing a fairly typical loft that does have some insulation in there, but it's got lots of missing bits. And then on the right, we've got a wall there with no insulation in, and we've got some very cold surfaces. There are a variety of different types of insulation materials, and there's a few things to think about when we are considering these. So firstly is the environmental impact of the insulation material itself. That can vary quite a lot between something that's made from sheep's wool, for example, or something that's derived from fossil fuels. We need to think about their moisture-related properties. So, how do they handle moisture? Can moisture pass through it, or will it trap moisture potentially in certain places? Different insulation materials have different levels of performance, and different ones might be suitable in different places. And it's also really important to think about the stability and durability. So again, particularly important in community spaces. if you've got groups of people kicking footballs against wall insulation, have we thought about that? How long might that be durable and how long might that last? We might also need to think about the application process. So some of them, like loft insulation, can just be rolled out across your loft. Some of them might need to be mechanically fixed into walls. And we also need to think about things like fire safety and toxicity as well. And then ideally, we also need to be thinking about what happens at the material's end of life. So how do we remove it? Can it be recycled? Can it be repurposed? Yeah. Why? I can't move my slides. You just click. Okay. So wall insulation can be applied internally, externally, or in a cavity if you have one. Most solid walls that you come across will be traditionally built. So if anybody's talking about solid wall insulation, you do need to remember that those buildings are generally traditionally constructed with vapor permeable materials, so lime mortar again. And if we are dealing with traditional buildings and traditional materials, we need people that are trained and competent to work with those materials. Geographic location and local exposure is a key factor, and not all cavities are suitable for filling. So it might be that you're in a particularly exposed location, or it might be that you have an older cavity. So yeah, not all cavities can be filled or should be filled. We've got a couple of pictures there just showing how a solid wall might look if it's made of brick. There are different variations to that, but that's just to give you an idea. And then the cavity wall is we've got the two sort of skins or layers of brickwork, and then we have a gap in between, and that's our cavity. We've got our map there again, just to sort of remind you all about location, exposure, and local context. So insulating our roofs, I think most people across the sector sort of agree insulating roofs is generally a good idea. It is generally considered quite easily to do, but it can be quite easy to get it wrong. You need to understand why and how timber roofs are ventilated, so that's quite important. Flat ceilings can be fairly simple. Sloping ceilings, or where you've got something called a rooming roof, that can often be a bit more complicated. So what I mean by flat ceilings, so in lots of our buildings, if we've got a flat ceiling here, we can insulate above the ceiling, and that can be fairly straightforward. It gets a bit more complicated where we might have bits of sloping ceilings, because we might need to remove the underside of the ceiling or remove from the outside some of our roof tiles to be able to actually insulate the sloping ceilings effectively. There is something called warm roofs. So this is where we're insulating up in this line here. So that can be a bit more tricky because you need to think you're fighting with gravity, so it needs to be fixed into place. And then this is the sort of rooming roof bit. So that can be a bit more tricky. We've got lots more junctions. We've got a larger surface area. So we need to be a little bit more detailed and give it a bit more thought before we do those. Suspended floor insulation. If you are going to be considering this, it is really, really important that somebody has checked that your floor timbers are actually dry. There should be a gap beneath any floor insulation between insulation and the ground. I've mentioned that the timbers need to be dry and in a good condition. Air bricks, so for people that aren't necessarily familiar with air bricks, you tend to see these anywhere where you've got suspended timber floors. You will have these little air bricks here going through your wall, and that's to let ventilation come through. So timber roofs and timber floors do require ventilation, and that is so That's to remove excess moisture and to prevent any sort of damp problems and to prevent rotting any timbers in our roofs and our floors. So yeah, the ventilation of them is quite important. Worth bearing in mind that doing things like suspended floor insulation or even solid floor insulation, they are quite intrusive and they are quite a sort of serious undertaking. So it's worth considering that they're often simpler things that you can do that might be cheaper and more effective, that might be helpful. So windows and doors, I mean, generally it obviously will depend on the windows that you've got, but if you can renovate and repair, it's worth exploring that before you jump to the conclusion of replacement. Curtains, shutters, they are effective and affordable. So even if you can't necessarily afford new, there might be things that are possible. If you are changing windows and doors, explore viability of wall insulation. If you are looking at new windows, there are various options in terms of different materials and U values. So you also might want to think about the embodied carbon of these materials. So if we are thinking about new windows, do you want to consider things like wooden windows, or do we want to go for plastic windows? How well they're installed really does greatly impact the performance. You could buy the best, fanciest windows in the world, but if they're not installed well, they're probably not going to be performing very well. So enclosed entrances, where practical, things like double doors you see in lots of little supermarkets these days, they can be a really, really good way of reducing heat loss. The picture on the right there, I'm not going to talk through it, but it basically just shows that there are lots of other things that you can do to buildings that do really reduce heat loss. I'll pick out a couple. Secondary glazing and adding shutters can reduce heat loss by 75%. Even by just doing things like blinds and closing shutters, that can have quite a meaningful impact. So yeah, there's often things that can be done before considering new. So it's often said that draft proofing is more effective than adding insulation. And the reason for that, I guess, is it's far simpler, it's usually cheaper, and it's often easier. Can reduce heat loss by up to 20%, but it is essential that we strike a bit of a balance here because yeah, while we want to reduce drafts, we also do need to maintain a healthy indoor environment. So ventilation provision is essential. So if we have buildings that are too airtight and not ventilated properly, we'll get bad indoor air quality, and we might have issues with that. If we have a building that's too drafty, we're going to have excessive heat loss, and that in itself might give us some issues. So I think the trick is here to try and hold on to the idea of balance to give us a healthy indoor environment. We've already talked about moisture and ventilation a bit, but it really is quite important, particularly if we are doing any other modifications to the building's fabric. I think we've previously mentioned different building fabrics, whether it be modern or traditional. They manage moisture in very different ways. You're aiming for a moisture balance. Robin's mentioned monitoring. So things like looking at your humidity levels, your air temperature, and CO2 is a really, really important indicator. So back in the days of the COVID pandemic, I think our government issued CO2 monitors to every state school in the country. And the idea was, if you had a high level of CO2, they were quite simple. They had a little traffic light display on them. So if it went to red, potentially you had an issue. Open the window until we've ventilated the space enough, and then we might be able to close the window again. So it really is a helpful little thing to look at. And just lastly, I guess on that, it really is quite important because it does affect our health and well-being. And if we are making retrofit changes, they can affect this both positively and negatively. So there are a few different things you might want to look at. We've mentioned air temperature, humidity, CO2. I'm not going to go into VOCs, that's volatile organic compounds, because they get quite scary. But I think we do have some guidance on our website somewhere if somebody wants to do some reading. There's different methods. So you might have like this image here. These little sort of desktop ones that you can leave in a space. Some of them are magnetic, so you can put them on a fridge or something. There are different systems. There are some that are more portable that you can take around with you, and that will just sort of beep at you if you get any issues. So it really can be quite informative to think about these things. So yeah, why are we doing this? Stronger community assets, so improved energy performance, resilience, usability, and comfort of community buildings through reduced energy cost. Warm welcome spaces. Community buildings, as I'm sure a lot of you know, they can be known for also giving energy advice. Changes you make to your building might help to inform or inspire changes for people that use your building as well. Yeah, so it's a good idea. Supporting well-being of users and normalizing energy conversations. So if you are thinking about getting low carbon heating systems or putting solar panels on, yeah, it's really good to think about how that can sort of help to spark conversations in your local community.
So yeah, that's it from our slides. I think there was one question actually in the chat, in the Q&A box. There was a question around external treatments that can be applied to external render to better insulate it. Probably the best thing I would suggest there is some form of external insulation. I'm not that actually aware if there are any external treatments, and I'd kind of be wary of how effective they would be. Probably the best thing is to assess the building for external insulation, which in turn would require its own kind of additional render layer or a cladding layer to make it wind and watertight. That's probably the more robust option. We always kind of are wary of things that can be sprayed or stuck on. Ideally, anything you do to your building should be reversible, which is why we're sort of always very cautious about things like underfloor insulation, sort of foam sprayed underfloor insulation, those kind of things, because if there's issues with the timber, then you could end up with problems that affect the whole floor and you'd have to replace the floor. The same with spray on loft insulation. Again, we wouldn't, kind of recommend that because if you have any issues with the timber, any damp problems, then it could mean that the timbers can't breathe, the moisture can't escape, it's not reversible, and you may end up having to replace the whole roof. And there are also, I think, some insurance issues around those kind of treatments. I think there's one other question.
The only other bit I would add to that is it's hard to know without sort of knowing, is it a modern building? Is it a traditional building? What is your render? Is it in what sort of conditions it in? So yeah, the more you can sort of answer some of those questions and look into that, I guess the better able, or the more informed you might be. What I'm after, the better decisions you might come to.
Yeah.
And just on the batteries and the solar panels, it's a really good idea. The more information you can get in terms of when you're generating your solar power, when you're using energy in your building, the more you can sort of take a better decision there. It can be quite tricky. Some buildings don't get batteries because they don't think it will be a benefit to them. So yeah, the more information you can gather when it comes to who's in your building, when you're using energy, how much you're using energy, the more you can sort of track that. Yeah, I would suggest there is a document somewhere out there. If you search for battery storage guidance for village halls, it's probably one of the better guides I've seen. So yeah, maybe give that a search.
Yeah, but in theory, if your usage or your demand is happening outside of the hours where the solar is generating its most, then a battery in theory could be a good viable option. But there's also, a sort of a cost benefit analysis in terms of how much energy you use outside those periods versus how much the battery costs to install and purchase and everything. And there was a follow-up comment on the first question about the external treatments. It's a heritage building with a high tower. I would, in that case, say probably a external treatment is probably not suitable for that kind of building. Even possibly external insulation is potentially not suitable if it's a heritage building, depending on its age. If it's listed or in a conservation area, it might be important to maintain the external appearance of the building. There might be requirements to do that. So there might be some other options to consider.
I guess I'd just have a look at Historic England's website. They really do have some good guidance around heritage buildings.
Thank you for that. I hope that was really helpful. I think that's all the questions we had in the box. We are running other sessions, so there are going to be some other sessions available. That's the date of the sessions there. If anybody is interested, please do feel free to sign up, share that with your networks and your partners. As I said earlier, the slides will be sent out and shared on our website. Thank you very much for your time this afternoon. I hope everyone found that helpful, and we'll see you next time. Thank you.